All right, welcome to The Explainer. Today, we're jumping into one of the biggest debates in science, Newton versus Einstein. Now, this isn't about who is smarter, because that's impossible to answer. The real question is this: whose work had the bigger impact? Who really, truly changed the world more? Let's get into it.
So in one corner, we've got the legend himself, Isaac Newton. This is the guy who famously saw an apple fall and realized, wait a second, the force pulling this apple down might be the exact same force keeping the moon circling the Earth. That idea? It was revolutionary. It gave us this vision of a perfect, predictable, clockwork universe, all running on a few beautiful universal laws.
And in the other corner, Albert Einstein. Now, Einstein didn't just, add a new chapter to Newton's rulebook. Oh no, he threw the whole book out and rewrote the entire language of reality. He looked at that fixed, predictable stage that Newton built, space and time, and said, actually, that stage isn't fixed at all. He showed us it's a dynamic, stretchy fabric, a spacetime that can bend and warp. I mean, nobody saw that coming.
So, just to be super clear here, we're not trying to figure out who had a higher IQ. That's a pointless question, right? What we are trying to figure out is something much more tangible. Whose ideas, when all is said and done, had the deeper, more lasting impact on, well, everything. On science, on society, on how we see ourselves in the universe.
Okay, so to make this fair, we're going to structure this like a good old-fashioned face-off. We're going to pit these two giants against each other in 3 rounds, looking at their legacies from a few different angles to see how they really compare.
So here's how we're going to score this thing. First up, round 1 is all about predictive power. Basically, whose math was better at telling the future of the universe? Then, in round 2, we'll look at technological impact. Where do their ideas actually pop up in our everyday lives? And for the final round, round 3, we're talking philosophical shockwaves. Who really blew our minds and changed how we think about reality itself?
All right, let's dive right into round 1, predictive power. This is all about the raw mathematical ability of their theories to predict what's going to happen. You could say we're asking, who was the ultimate cosmic fortune teller?
Newton's laws weren't just powerful, they were like a scientific superpower. I mean, they were so incredibly precise that Edmund Halley used them to predict the exact year his comet would return. And then, get this, decades later, astronomers noticed the planet Uranus is kind of wobbling in its orbit. So they plug it into Newton's equations, and the math basically screams there's another planet out there pulling on it. They point their telescopes where the math told them to look, and boom, there's Neptune. Unbelievable.
But then you have Einstein and his predictions. They were just on another plane of reality. First, he solved a little puzzle that had stumped Newton's physics for decades, a tiny wobble in Mercury's orbit. But then he made these wild predictions that sounded like pure science fiction. He said that the sun's massive gravity would literally bend light from distant stars. And sure enough, during a solar eclipse, they checked, and he was right. He even predicted ripples in the fabric of spacetime itself, gravitational waves. It took us 100 years and billion-dollar detectors, but we found those too.
Okay, so how do we score this round? This is a tough one. It really feels like a split decision. When you think about sheer breadth, covering pretty much everything we experience in our normal lives, you got to give it to Newton. But when it comes to depth, peering into the most extreme, bizarre corners of the universe, the point has to go to Einstein. So after round 1, it's a draw. We're all tied up.
All right, on to round 2. Let's bring all this high-level physics down to Earth a bit. The question here is simple. How do their big ideas actually affect the technology we use every single day?
And let's be real. The world we live in is, for the most part, a Newtonian empire. I mean, every single bridge you drive over, every skyscraper you see, the engine in your car, all of that is built on the foundation of his mechanics. Even putting satellites up in the space, that starts with Newton's math. It is, without a doubt, the basic operating system for all of engineering.
But, and this is a huge but, so much of our most advanced technology runs on Einstein. Take the GPS in your phone. You use it every day, right? Well, it only works because the satellites orbiting Earth are constantly correcting for Einstein's theories of relativity. Time literally ticks a tiny bit faster for them up there. If we didn't account for that, your GPS would be off by miles within a day. And that's not even mentioning lasers, solar panels, or, nuclear energy, which all have roots in his work.
So this round is another really tough call.
isn't it? On one hand, you have Newton's massive physical footprint on our world, the infrastructure we can see and touch. On the other, you have Einstein's impact on the invisible, high-precision technology that makes modern life possible. I think we have to call this one a draw too. It's just too close to call. So heading into the final round, the score is still even.
Okay, this is it. The final round. We're moving beyond tech and engineering and into the deep stuff, the philosophical shockwaves. The question is, whose ideas delivered the bigger jolt to our very understanding of what reality is?
You see, Newton didn't just give us a bunch of laws. He gave us the playbook for modern science itself. This whole method of, okay, describe a system with math and then use that math to make a prediction you can actually go out and test, that's Newton. And it led to this incredibly powerful idea of a deterministic, clockwork cosmos, a universe where if you could just know where everything was and how it was moving, you could predict the entire future with perfect accuracy. A giant cosmic machine.
And then Einstein came along and just smashed that clockwork machine to pieces. He kicked off a complete paradigm shift. He showed us that the very stage the universe plays out on, space-time, wasn't this fixed absolute thing. It was alive, dynamic, it could be warped and curved. He proved that time isn't universal. Think about that for a second. The now you're experiencing is not the same now for someone moving at a different speed. And of course, he revealed that mass and energy are just two different faces of the same fundamental thing.
Okay, for this round, I think we have a clear winner. If we're judging on pure, mind-bending, everything you thought you knew is wrong, shock value, Einstein takes it, hands down. Newton gave us the method to draw the map, but Einstein came along and told us the very paper the map was drawn on was warped. He didn't just refine our picture of reality, he completely shattered it and gave us a new one.
So, the face-off is done. But let's take a step back from the competition for a moment. How does modern physics actually see these two? Is one right and one wrong? What's the real relationship between their worldviews?
This is probably the single most important thing to understand in this whole discussion. It is so tempting to say that Einstein proved Newton was wrong, but that's just not how science really works. It's not the right way to think about it at all.
What this really shows is a beautiful idea in science called domains of validity. Here's a great way to think about it. Imagine Newton gave us a perfect, incredibly detailed street map of our city. For getting around town, it's all you'll ever need. It's not wrong, it's just limited. But Einstein gave us the entire globe. Newton's laws are an almost perfect approximation for the world we live in, the world of relatively slow speeds and weak gravity. His brilliant map is just neatly nested inside Einstein's much bigger, more general one.
So even today, Newton is the absolute workhorse of physics. We use his equations to send probes to Mars, to build bridges, even to figure out the perfect arc for a basketball shot. But Einstein, he provides the fundamental operating system for the entire cosmos. His physics is what we use to understand everything from the Big Bang to what happens inside a black hole.
Okay, so after all of that, where does that leave us? What's the final takeaway? Who really changed the world more?
You know, the real verdict isn't about picking a winner. It's about understanding their different and totally complementary roles. You could say Newton was the ultimate builder. He handed us the blueprints we needed to construct modern civilization. But Einstein? He was the ultimate explorer. He didn't give us blueprints for building things. He gave us a completely new map of reality itself, one where space, time, and gravity were things no one had ever dreamed of.
So in the end, maybe the true winner isn't Newton or Einstein. Maybe the real winner is the method they both perfected. This incredible process of having a bold idea, expressing it with the beautiful clarity of math, and then, and this is the crucial part, ruthlessly testing it against what the real world tells you. That was the engine that drove both of them. And it's the same engine that keeps pushing us forward today, always looking for that next, even deeper understanding of our amazing universe.